Okay, so let's go ahead and do a slightly more complicated example. We want to find the slope of the tangent to a circle. And I'm going to do this two different ways. We're going to look at the circle x squared plus y squared equals 25, which, as you probably remember, has a center at the origin and a radius of 5. And we're looking for the slope at the point 3 comma negative 4. So I can already see that I'm expecting a positive number. And first, what I am going to do is I'm going to write this as an explicit formula. And I get y equals the square root of 25 minus x squared. But I also know that I need the bottom half. So I actually get y equals negative square root of 25 minus x squared. I'm going to write this as a power because I know that it's much easier to do the derivative or take the derivative if it's a power. And now I know that the derivative of y with respect to x equals, let's quickly do outer and inner just to keep track. So it's the derivative of the outer, which is negative 1/2 25 minus x squared to the negative 1/2 times derivative of the inner is going to be negative 2x. So doing a little simplifying, I get the derivative of y with respect to x. The negatives will cancel each other out. The 2's will reduce. And I'm left with x over the square root of 25 minus x squared. And if I evaluate it at the point at x equals 3, what I get is 3/4. So we'll draw a little tangent line here, and sure enough, looks to me like that has a slope of approximately 3/4. And so we're good. That wasn't that hard, a little complicated, chain rule, blah, blah, blah. So let's go and take another look at this. But this time, we're just going to leave it just like this. So step one, and I am going to label these steps because we're going to put together a process. Take the derivative. Derivative of y with respect to x. Well, derivative of x squared is 2x. The derivative of 2y is 2y. And then the chain rule says I have to multiply that by the derivative of y equals, and the derivative of 25, of course, is 0. Step 2, I'm going to get the terms with dy dx on one side. I'm going to collect them. So I'm going to have 2y dy dx on this side. I'm going to have negative 2x on the other side. If I needed to at this point, I could factor out the dy dx's, but in this case, I only have one term, so I can skip that and I can solve for dy dx. And I'll just do that by dividing both sides by 2y, and I get that dy dx equals negative x over y. So if you remember, my problem was I wanted to know the slope at 3 comma negative 4, and this will be 3 over negative 4 with a negative out front, gives me 3/4. Exact same result, but honestly, this is a little bit more straightforward. A very straightforward um, um, derivative, excuse me, and a pretty straightforward solve for dy dx. Gave us the same answer, but this had a much more complicated derivative. So let's take a look. Well, tell you what, meanwhile, why don't those of you in my class go ahead and do exercise 11? You can pause the video and do the exercise. Okay, welcome back. So let's look at another example. I've got the function 2y equals x squared plus sine y. And rather than finding the derivative at a particular point. The question here is, does the derivative exist everywhere on this graph? And there are just all sorts of, reasons why you might want to know something like that. We're not going to worry too much about the whys, but let's do it. So the first thing I'm going to do, step one, I'm going to take the derivative. So the derivative of 2y is the 2 times, then chain rule says derivative of y. Derivative of x squared is 2x plus the derivative of sine y. Well, the derivative of sine is cosine. Chain rule says times the derivative of y with respect to x. All right, step two, collect. I want all the dy dx's on one side. So I've got 2 dy dx minus cosine y dy dx equals 2x. Step three is to factor out the dy dx's. So I've got dy dx times 2 minus cosine of y equals 2x. And step four is to solve. The derivative of y with respect to x is 2x divided by 2 minus cosine y. Now, if I had particular points, of course, I could plug them in. I could do all my calculations. But the question here is, does this exist everywhere? Well, we know that there is a place it doesn't exist. So dy dx does not exist when 2 minus cosine y is equal to 0. But that means it does not exist when cosine y is equal to 2. But cosine y cycles between -1 and +1, which means that it always exists, because there is no place where cosine y will be equal to 2. All right, let's very quickly just write down this process. And number one, you're going to take the derivative with respect to x. You're going to use your chain rule. You're just going to work your way across. Number two, you're going to collect the dy dx terms on one side of your equation. Number three, you're going to factor out the dy dx. And number four, you're going to solve for dy dx, which, since you just factored, generally just a matter of dividing by the stuff that you were left with when you factored. All right, so if you're in my classes or if you're just following along, go ahead and do exercise 13 in the book, and we'll be back with the next video. Thanks for watching.